Okay, YouTube, in our last video we looked at writing equations that represent functions of x, typically y is a function of x. And in this video what we're going to do is we're going to introduce what we call function notation as opposed to xy notation. We have x and f of x notation. So let's go ahead and start with this. In terms of our last video, we had looked at a function, for example here, and saw that this function right here represents y as a function of x because y is isolated on one side and because every x value we plug in we only ever get one y value back. But because y is a function of x, often what we do is we give this a name. We refer to this as a function of x or f of x, which is what you see right here. And so this f of x, let's go ahead and acknowledge a few things here. Our x value is still our input value or our domain value, but our output values, instead of y, okay, we're going to use f of x instead. And so one thing we want to acknowledge is that y, or the output, and f of x, or is the output, they are the same exact thing. It's just that we're giving this function a name f. And we could also, by the way, while we're at it, we could give it a different name here. We could give it, say, g of x. We could call it h of x. The idea here is this. We would say that f, this is the name of the function, okay? And so our x, okay, this is our input or our domain entry, okay? Our f of x, what I'm going to write here is our function value, or in other words, our y value at the input x. And so in order to find the y value at x, we could go plug x into our function here to find our function value at x. And then we would just say that this equation here, a name for this equation is just a rule that tells you how to find a y value if you know the x value. So what I'm going to tell you here is that although f is often used, you can use any letters that you want. And as an example, we could say that f of x could be, for instance, this function here, function of x. But we could also say f of t and use t instead. Maybe our input is time as opposed to, say, x, which may be like a distance or something. Or you could even use an s. But the idea is this: it doesn't matter what letter you use. That letter really is just a placeholder for input. And so in other words, in each of these instances where you're seeing a function of x or a function of t or a function of s, the thing that's changing here is our independent variable or the input. And what we do is we place that into the function for every input field. So for instance, this function that you see here, f of x equals x squared minus 4x plus 7, would be the same thing as f of box equals box squared minus 4 times box plus 7, where wherever I put in here, say I put in a 4, then I would have to put in a 4 over here for all of the input fields. So what I want to do is basically just evaluate this function for these given input values, and then we'll go ahead and verify these graphically. And so we would say that g of x is this function here, negative x squared plus 4x plus 1. When we say g of 2, really all we're saying is let's go find the y value of our function when x equals 2. So a couple things here. First of all, this negative here does not get squared unless we put parentheses around both the x and the negative. So when we put in our 2 here, our g of 2, we're going to put in a 2 everywhere I see an x over here, and we're just going to evaluate this. We say that our function value of g at x equals 2 is negative, let's see, 2 squared here is 4. 4 plus 4 times 2 is 8 plus 1, and then we'll go ahead and do this left to right here. We get negative 4 plus 8 is 4, 4 plus 1 is 5. And so when we say g of 2 is 5, I'm going to put a box around this. We want to know this. It is the same as when I plugged in 2, I got 5. Okay, and that's the same as when I plugged in here, we say x, g of x. We say when I plugged in 2, our g of 2 value came out to be 5. So in other words, our g of x is always representing an output value or a y value here. So let's go and take a look at letter B. Most of the time when I show this to people first time through, they're like, well, how do I do this? It's just a letter. And the neat thing about it is you still do the same thing. That is, you still take out all of our inputs that we have ready to go, and we plug in whatever it is that we were asked to plug in, which in this case is just t. So g of t, the output of our function, if x is equal to t, is always negative t squared plus 4t plus 1, whatever that equals. Okay. So now for letter C here, we have g of x plus 2. So now one thing we want to be keeping in mind here is that our input is whatever is in this field here. So do not get, don't let it mess you up here that it's got so much substance in there. What we're going to do is the same thing. We're just going to use a direct substitution. So everywhere we see an input, we're just going to put in this squared here. Now this one is a little bit different this time because we actually need to simplify what we have on the right side. So g of x plus 2, the first thing I want to do is I want to go ahead and square this x plus 2 here. And I'm going to go ahead and distribute my 4 throughout this as well. So we get 4x plus 8 plus 1. Looking at these, looks like we have some like terms we can combine here. So here's what I'm going to do in this case. Let's go ahead and I'm going to save this negative out in front here. I'm going to go ahead and FOIL these two first. So I'm going to put negative 1 out in front of what we get. But taking x times x, we have x squared. X times 2 is 2x. 2 times x is another 2x, and then 2 times 2 is 4. Looks like we get a negative all of this stuff here, plus our 4x, plus our 8 plus 1, which is plus 9. And in this case, what we're going to do is we're going to combine these two x's here and then distribute a negative throughout. And so what we end up with is this. We basically get a negative x squared. This 2x plus 2x is 4x, but when you distribute the negative through, it makes them negative. So we get a negative 4x, and then we get a minus 4 here, plus 4x plus 9. And then what we're going to say is then finally g of x plus 2, what we get when we plug x plus 2 in our function is this new function, negative x squared. We could put our negative 4x and our positive 4x together. They cancel out. And then our negative 4 and positive 9 gives us a 5. So this would be right here our function value, negative x squared plus 5, if we plug x plus 2 into this function. So direct substitution can be used to evaluate a function at any of those given input values and give you an output value. Cheers.